Hello, my name is Gurunath Sanjay Bandivadekar, roll number 374. My presentation topic is on determination of shear strength of unconfined compression test. So, general introduction about this test. The unconfined compressive strength that is QU is the load per unit area at which the cylindrical specimen of a cohesive soil falls in compression is called as unconfined compressive strength. The unconfined compressive strength is a special type of unconsolidated under capital UU test that is commonly used for clay specimens. It is a special case of triaxial compression test. In this test, the confining pressure, that is sigma 3, is 0 in this cylindrical soil specimen with height to diameter ratio of 2 to 2.5 is loaded axially by a compressive force until failure takes place. There is no rubber membrane is necessary to encase the specimen. The vertical compressive stress is the major principal stress, that is sigma 1, and the other two principal stresses are 0. This test may be conducted on undisturbed or remolded cohesive soil. It cannot be conducted on coarse-grained soils such as sands and gravels, as this cannot stand without lateral support. Also, the test is weak or undrained one because it is assumed that there is no loss of moisture during the test, which is performed fairly fast. So objectives of the test first is to determine the unconfined compressive strength of a cohesive soil sample, which is an unconsolidated undrained, that is capital UU or Q type test, where the lateral confining pressure is equal to 0, that is atmospheric pressure. Then applications of this test. This test is widely used in different engineering related projects to evaluate the stability of structures against loads, the loads design and stability analysis of foundations, retaining walls, slopes and embankments to obtain a rough estimate of the soil strength and determine the visible construction techniques. Then apparatus required for the test. First one is compression machine, then proving ring of capacity 500 Newton and 1000 Newton with list count of 1.0 and uh, zero point 0.1 respectively. Then dial gauge with list count 0.01 mm. Then split mold of internal diameter 38 mm and length 76 mm. Then sampling tube of internal diameter 38 mm and length 200 of accuracy 0.1 gram. Then sample extractor, then stopwatch, then scale, nib and grease or oil. This is the diagram of ring type compression machine. Here you have see the different parts of compression machine like motor, bottom conical plate, strain dial gauge, top conical plate, frame and proving ring. Then procedure. First 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 step is to push the sampling tube into the sample, to remove the sampling tube along with the soil. Then saturated the soil sample in sampling tube. Then coat the inside of the split mold with a thin layer of grease or oil to prevent adhesion of the soil. Then extrude the specimen from the sampling tube to the split mold with the help of sampling extractor and nib. Then trim or cut the two ends of the mold like this. The figure 1 shows the trim or cut the two edges of the specimen or ends of mold. Then weight the soil sample and mold. Then remove the soil sample from the mold by splitting it into two parts and then measure the length and diameter of the specimen. Then place the specimen on the bottom plate of the compression machine. Then raise the bottom plate of the machine to make contact of the specimen with the upper plate. then adjust the strain dial gauge and proving ring dial gauge to read 0, then apply the compression load by raising the bottom plate of the machine to produce axial strain at a rate of 1.222% per minute, then record the strain and proving ring dial gauges readings every 30 seconds, then compress the specimen till it fails or 20% vertical deformation is reached, whichever is earlier, and last one is note down the rest count of the strain gauge and load dial gauge. Here you have see the some picture related to this test. Uh, First one is to cut or trim the two ends of the mold. This picture, second figure is shows this. Then fix it on ring type compressive machine. Then apply the load. Figure number 3 shows. Then apply the load. Apply the compressive load. Then failure is occurs like this. Here you see the different types of failures occurs in the sample like this. Then this is the observation table. The points included in elapsed time, then dial gauge, proving ring, then strain, corrected area and compressive stress. Due to this test, we can check the various parameters of the soil like unconfined compressive strength, then second is sensitivity of soil, then shear parameter of the soil, etc. Here you have see the some definitions which related to this test. The another definition which is on unconfined compressive strain, that is QU, is the ratio of failure load to the cross sectional area of the soil sample. If it is not subjected to any lateral pressure, then you can write the QU is equal to P is divided by AC, where QU is equal to unconfined compressive strain and P is equal to failure load and AC is equal to corrected area at failure. Here you can multiply and rearranging the formula like this. Here you see at the bottom there is E is equal, rearranging the formula is E is equal to delta L divided by L0, where delta L is equal to change in length and L0 is equal to initial length of the sample. From this formula we can easily find out the unconfined compressive strain, where the water content of the soil is assumed to remain constant during the duration of the test, which generally takes only a few minutes. Here you have see the relation between consistency of clays and compressive strength. At the left side, unconfined compressive strength in kilonewton per meter square are given, and at the right side is consistency. Unconfined compressive strength is less than 25, then consistency is very soft, between 25 to 50, then consistency is soft between 50 to 100, then medium 100 to 200, then stiff, then 200 to 400 very stiff, and greater than 400 is hard. Then definition of sensitivity, it is denoted as ST. It is the ratio of unconfined compressive strength of undisturbed soil sample to the unconfined compressive strength of remolded soil sample at a constant moisture content. Here you see the soil classification on the basis of sensitivity. When the sensitivity is 1, then insensitive clays, sensitive, then sensitivity is 1 to 2, then nature of the clays low sensitivity clay, then 2 to 4 medium sensitivity clay, 4 to 8 sensitivity clays, and 8 to 16 extra sensitivity clays, and greater than 16 quick clays. Then we can find the cohesion from the following formula, that is sigma 1 is equal to sigma 3 into tan square alpha plus 2c into tan alpha, where sigma 1 is equal to major principal stress at failure, then sigma 3 is equal to minor principal stress at failure, and alpha is equal to failure angle with major principal plane. When the angle of internal friction, then alpha is equal to 45 plus 5 divided by 2. In unconfined, and sigma 1 is equal to Qu, that is unconfined compressive strength. Then we can easily find out the shear strength by using Coulomb's equation, like tau F is equal to C plus sigma EF into tan phi, where tau F is equal to shear strength and sigma EF is equal to effective normal stress. If phi is equal to 0, then tau F, that is shear strength, is equal to C. Here then sample calculations are using this formula. The sample calculations are done and the following result is obtained, like unconfirmed compressive strength in kilonewton per meter square or newton per mm square, and shear strength in kilonewton per meter square and newton per mm square also. From the recorded value of strain and proving ring dial gauge reading after every 30 seconds interval before failure, we will draw the stress strain curve. At the stress strain curve on semi-logarithmic graph paper, you have see the image of stress strain curve. On x-axis stress in mm are given, and on y-axis stress in newton per centimeter square are given, and then the nature of the graph is like this. Then draw the Mohr circle. We can easily draw the Mohr circle for stress condition at failure. As the minor principal stress is 0, the Mohr circle passes through the origin. The failure envelope is horizontal. The cohesion intercept is equal to the radius of the circle. You have seen the Mohr circles for unconfined compressive test, where sigma 3 is 0 and sigma 1 is equal to Qu, and they plot the Mohr circle. Then advantages of this test and inexpensive. In this test, thin sample allows for the rapid drainage of fine grained soils, and the disadvantages is failure plane force to occur at a joint in the box. Then second one is only for drain conditions, and third one is it is non-uniform distribution of strain and stress. Thank you.